Okay, welcome everyone, and thank you for joining us here in the sixth of our Demystifying Data Masterclass series with CIRDAS and SureTech Network Centre in Carlow, and being delivered by Mick of Describe Data. For those of you who don't know me, my name's Damien Rosser. I'm the Programme Manager for CIRDAS. We offer free and heavily subsidised education solutions from the likes of this masterclass through to level 8 and 9 certificates and level 8 and 9 major awards. So if free education is what you're interested in, get in touch with myself. If you're a fintech or an insurtech and you would like to know more about supports from Enterprise Ireland, get in touch with Aidan of the InsurTech Network Centre. I'll pop those details in the chat. I'll pass you over to Mick now in a minute, but just a quick bit of housekeeping, the usual. Try and keep the mics off unless you're speaking, and then if you want to get involved, pop something in the chat. And without further ado, I'll pass you over to the capable hands of Mick Cooney of Describe Data.
Sure, that's it. Thanks, Damien. And Demi, you can hear me okay, yeah?
Yep.
Just make sure. Excellent, great. Okay, well, thanks everyone for coming. I won't stand on ceremony. I'm just going to make the broad assumption that most people have been at least a few of my previous ones, so you kind of know the format now. But just to reiterate, this is much more about you than it is about me. I'm just the guy talking. So if any of you guys have questions or comments or want me to elaborate on anything, or even just talk about something random that's vaguely connected to data, we can discuss it at the end. Don't be shy. Please pop stuff in the chat. Damien is going to keep an eye on the chat for me, just if anything kind of comes up, and I'll probably periodically check in because sometimes it's a bit hard to see the chats when I'm presenting on full screen. Yeah, and we'll get started. So you'll for those of you more sharp-eyed, you'll notice I'm in a bit more formal attire today, and that's because I'm actually giving this from the Lloyd's building in London. I'm in London for the next couple of days. Sorry, from yesterday to today, flying back tonight, and yeah, so it's actually nice to be, essentially, probably if there was one building in the world that is insurance related, it's the Lloyd's building in London, which is the Lloyd's of London, not Lloyd's Bank, that a lot of people mistake. And they get very annoyed about that because one has an apostrophe and the other one doesn't. The Lloyd's of London has a apostrophe S. Although I was just telling Damien earlier, my parents came over to see London a couple of years ago when I was here on a very regular basis, because they'd always gone down the West End and they weren't really much in the city, and I was kind of showing them the buildings. And my mother was incredibly unimpressed with the architectural marvel that is the Lloyd's building. She thought it looked a lot like Sean Quinn's concrete factory, and the lady was not for turning. So yeah, so I guess taste is a very individual thing. But yeah, so today basically we're going to continue. This has been a bit led by you, which is great. Like I said, we kind of had an 8-week high-level program that was more indicative than anything else. And as a result of some conversations we've had over the last couple of weeks, people have asked they would like me to talk a bit more about data visualization, which I kind of discussed as part of AI and as part of keeping things simple and a few other topics. People are like, yeah, we'd like to know a bit more about data visualization. So now it's a very big topic. I really am only going to scratch the surface on a couple of topics. So there's whole areas of things that I would love to be able to talk about and actually point at some research. But I did remember, because people have asked me, I've actually included a couple of books. And I think I've put the links to the book. I might have put the Amazon links. I've put some links anyway, some images for a couple of books that I think I've found useful. 2 of them I own, and I thought they were quite good. But yeah, so before we won't kind of stand on any more ceremony, let me just maximize my screen here. And yeah, so we're just going to talk about data visualization and some do's and some don'ts, probably more do's than don'ts. I'm also not going to get too detailed into I'm trying to keep this, when I give this talk, normally I'm talking to data people, and modelers and people who show up at meetups or in university or whatever. So that it's a much more practical thing, whereas I'm very conscious that the audience here is probably more of the receivers of the data visualization rather than the creators. But it is important to know a bit about it. So I've kind of blended those two a little bit. And what I'm trying to point out today is things you should be asking for, if you know what I mean, rather than things that you should be doing, which does make an interesting state. And it's entirely possible I didn't get the balance right. And if I didn't, I can only apologize and offer you a full refund. But if you have any questions or if there's stuff that just doesn't make sense, you know, sometimes I go on implicit knowledge that may not necessarily be in the audience. So please, you know, shout up and say, please explain what the hell you're talking about, Mick. I'm more than happy to go back over. So yeah, so I guess the first thing we're going to talk about is, what's the point? Like, why are we doing this at all? And the whole point of database is to tell a story. Like, ultimately, the reason why people use data for anything is to figure out something about the world, like to learn something. And it could be about your organization or about how effective a marketing campaign is, or trying to get some sense of the risks you've underwritten, or, you know, trying to get access to a market. You're trying to learn something about the world. And as a result, the data that you've collected on that needs to tell some kind of story. And it could be just, what do we have? Or the story could be the outputs of some very sophisticated machine learning. But humans are kind of programmed to understand and like stories. So it's always important to almost ask for the story, if you know what I mean, because that's, you know, typically it's not a one and done. You're also, you know, even if it's you're receiving some kind of outputs, you're then probably going to use that to either move it further up the chain or to make a decision or to deal with it, whatever it is. So always try and get the story out of the data. And the story could literally be as simple as, I mean, I'm really abusing the term story here, but it's, you know, what is it we found and how do we figure it out? So a good example here is we've looked at that motor insurance data that I showed you a few weeks ago. And we might just want to know, there's an exposure metric, which it's not entirely clear in the data, unfortunately, what the unit of exposure is. My gut feeling is it's some kind of duration. So it's like a policy year in car insurance. So we want to know, like, what's our exposure by region in France. So I've shown you a few of them there, and I've kind of collapsed them down, and you can see that, you know, we have the region Centre about, you know, and that's a table of the data, and that's one way of figuring it out. But and, you know, we can add a bit of formatting to it, so we put some commas in for thousands, and, you know, make it nice in 2 decimal places. All that, we could definitely do that. But a much better way of looking at it is just to create a graph of the data. You know, I think a thing people often do is they fall into the trap of presenting tables of data, which are very hard to read. Now, there are situations where you do actually need a very high information density to be able to do something, but those are, I've only ever came in a few very specific use cases for that. In general, it's more about taking stuff out than adding thing in. Like, because again, when you're telling a story, you're not telling everything. So like, if you look at, you know, Lord of the Rings, for example, they don't detail every single part of the journey because most of them are not really germane to the story you're trying to tell. And that's a very similar thing here, right? So showing less is actually absolutely fine. Just kind of boil down to the essence. What you should get from it is that you should kind of figure out almost exactly, no, sorry, let me rephrase that. You should figure out almost instantaneously what's been said. And it should be very obvious without needing a whole load of explanation about a chart. It's a bit like politics with database, and I say this a lot, like if you're explaining, you're losing. So it's very obvious here when you look at it that like the most of the exposure, you can actually learn a couple of things from this chart pretty much straight away, in that the center is, or Centre region has the majority of our exposure, that the Ile-de-France, Provence, and the Rhône-Alpes, you know, are what, about no more than half. And while we have a bunch of other regions, those other regions are relatively significant too, because it's not, even that we've kind of lumped all the rest into one big other category, but you can actually see there's quite a lot of exposure there. So with one very simple visualization, you can actually see, you get a sense of what's going on in the data straight away. Now, it's important to put your titles in. It's important to put, another key thing that we talked about in terms of the statistics stuff was lying is and there's some hilarious examples of that online that I haven't included in the post here, but you actually see it in a lot of mainstream media, especially ones like in the US that have a political story to tell. They have a tendency to abuse infographics to make things look a lot worse or a lot better according to whatever political point they're making. And I mean, there's a lot of stuff on Fox News, but I've seen quite a bit from like the MSNBC and CNN as well, where they're just basically not being entirely honest in how they make their point. But, you know, truth is usually a secondary consideration when it comes to politics. But you do see them. People do abuse these like graphics in a way. And a very great way to spot things is if you've got some kind of y-axis, make sure 0 is on the y-axis somewhere, and so that you don't. And we talked about that a lot more. So that's kind of we're telling a very simple story, but there's a bunch of different chart types you'll get, and there's I mean, one of the benefits and issues with a lot of modern day software is that they've made it very, very easy and very quick to do things, but what is very hard to learn is when things are appropriate and not. And we will talk about the notorious pie chart a little bit later because it came up a few weeks ago. And my answer to all of these is to just keep things very, very simple. I tend to go with just line plots and scatter plots. So I'll have bars, which is kind of like a line plot. And for like, if I have a time series element maybe, and the time is on the x-axis, I'll draw a line between the points because that, you visually get a sense of things from looking at it that way. If it's bivariate data where you've got, an X and a Y, where I think someone asked a while ago about, profit versus revenue kind of stuff, I would just use a scatter plot because again, that gives you a sense of, what's the relationship between these two variables. If you want to get a bit more fancy and you've got some kind of distributional thing, I'll use a histogram. I'm going to assume everyone knows what a histogram is. For those, if you don't, actually, I probably won't assume that, but it's basically you get a whole load of values and then you put them into bins, equally sized bins, and then you count how many data points go into each bin, and it gives you a sense of the distribution of numbers. And it's basically a bar plot, so they're very easy to kind of interpret and understand, and they're also quite well understood and quite well used. So most people, you're not trying to explain your visualization. And then sometimes as well, I'll use error lines, which is basically like kind of like a box plot, but I don't use box plots because I think I've mentioned this before. For those of you who know what a box plot is, I try to not use them unless I'm dealing with a very technical audience. And the reason for that is you end up explaining the box plot. And again, you're explaining, so therefore you're losing. However, I have found that error lines can be more useful than a box because there's just less going on. It's actually a much simpler thing. And I'll give you, I used an example of it a couple of weeks ago, and I'll show it again in a minute. So I don't really want to talk in the clouds. I'd like to get down into the weeds. So this is kind of a very example data set. It's kind of it's insurance related. So this is why I've been using it. And it's part of a package that is freely available in R and you can get on GitHub. And it's third-party liability motor from France. I'm not exactly sure when it was set. We think it's around the early 2000s, something like that. It's available at that website. These slides are all available online. So if any of you are interested, you can kind of get them from there. It's available in that. And it basically looks like this. You've got two sets of data in there. You've got a policy data, which has, it's a relatively straightforward thing. You've like this ID, how many claims are on the policy. This is this exposure measure that I was telling you before. It's not entirely sure what that's measuring. And then you've got a vehicle power, which looks like a number, but it seems to be some category. So it's 5, 6, 7. So this is the other thing you have to be careful of. Sometimes numbers are really words that have digits as letters. So you have to treat them like a categorical variable rather than a numeric variable. And we've got a bunch of values like that. There's a population density and there's different values in there. And then we have a claim amount as well. That's the second part of the data. So we're basically all the visualization is just to talk about some stuff. I'm going to use that today. So the very first thing we can look at, like I said, is there's about 700,000 policy roles with about 27,000 claims. It's a relatively, it's not necessarily an easy data set to work with if you're using Excel or something like that, but most modern like Power BI or Tableau or Python or R and any of them, they can handle this kind of stuff, no real problem at all. Or even like a SQL if you want to work with that. You can do that pretty straightforwardly now, whereas 10 years ago, personal laptops probably would have struggled quite a bit with it. So again, we're just going to show some very quick visualizations from it that this is what I would be showing you if you asked me to take a look at your data. This is kind of the things I would be looking at. So let's just look at claim rates, which is just kind of a frequency measure. On average, how many claims does an individual policy create? And we're looking at it by region. Now, this is a slightly bigger data set than the one from a previous one. So we have just points. So you can see this is effectively a scatter plot with a discrete x-axis and a continuous y-axis. And it just gives us a sense of, we can see that, there's a variation of claim rates across them very quickly. Just from looking at it, we can see the lowest is about 7.5 and the highest is about maybe 13 or 14 per 100. So that's, but again, it's very, very simple to look at. We're not really we're not pushing the boat out. And this can be very useful because it allows you to look at your own data and make sure that what you're doing is sensible. Because if there's a problem with this, then there's two things that could have happened. And this is why visualization and keeping things like really simple and unambiguous is important, is because humans are really, really good at visual checks of things. So, but we're also really good at identifying outliers to the point where we're actually too good at it, which is why is the joke I always make. It's why people see Jesus in a toasted cheese sandwich, or faces in clouds. It's because we're actually hardwired to read pattern even in completely random things. But we can actually, and while that's often a problem, we can actually harness it as well, because if we can create these kind of relatively simple plots, issues will get picked out straight away by people because they'll go, hang on, so let's say if you looked at this and you've got this course, which seems to be Corsica, like that claim rate looks, I might know that that's actually a really, really low claim area, and yet it's coming up with the highest claim rate there. So that means there's two things that have happened. Usually it means I've made a mistake. I'm not too arrogant to suggest there's a problem with the data. Usually I've either misunderstood what I'm looking at, or I've interpreted the wrong, or I'm using the wrong field, or whatever it is. Or sometimes there's a problem with the data, and that could be as simple as there was just a flaw in the extract and we just need to re-extract it and fix the SQL query, or someone just did something wrong. It happens all the time. The other thing could be that actually we've got a flaw in our data collection process that we need to fix. And again, this is why I always tell people to go back to some earlier weeks, always put your data to use as quickly as possible, because and create these really simple plots with, like I said, with dots and lines, because people will look at them, and if there's a problem, people are very, very good at spotting that stuff. But like I said, sometimes maybe we want the sense of the uncertainty. Again, calling back to some previous classes. So like I said, I don't like to use box plots, which will be a better way of doing this to a certain extent, but all I'm doing here is just getting an estimate of the uncertainty. And you can see I have these error bars. Now, this is a bad thing that I meant to fix and forgot. What I should put in here is tell you what those regions are. So this is actually an 80% region and a 50% region. So it's basically 25 to 75% and from 10% to 90%. And I should have that in the text. And you should ask for that from people and make sure people, because labeling is certainly for people like me who are technical, we tend to underestimate aesthetics a lot. And aesthetics are incredibly important for this stuff. It's also why I tend to go with simple things, because I am not artistically minded at all. So I kind of keep these things really simple because it's hard for even me to screw these up. Yeah, I've screwed up here. I just realized I meant to fix that. So what I should have put in there was 50% and 80% uncertainty regions. But what I said is it's kind of a line. So we can kind of get a sense, even if you didn't look at that, the reason why I kind of keep these, again, just drawing very simple lines and keeping it very simple, is that even if you didn't necessarily know what that regions were, you could probably tell that there's two statements of uncertainty here. And you can also kind of tell that, one isn't necessarily that much bigger than the other. So it's a relatively stable estimate of uncertainty, which is, not bad. But you can also see that some regions have very low, we're pretty confident of those estimates of the rates, but some of them are quite high. This French Comte is has quite a bit of uncertainty around it, probably going from anywhere from let's say 8% to 12%, let's say in the regions that in the uncertainty bands that I've shown you. And again, like I said, if you did this as a box plot, I think you wouldn't. There's more going on, so there's more questions getting asked. Whereas this way, it's nice, relatively clean, and relatively unambiguous. And you can basically explain this to kind of anyone in terms of. Now, people will then prompt to the question of, well, how did you calculate these uncertainties? But to me, that's a win, because if you're actually discussing that kind of stuff, it means I've actually got you interested, because that's the worst thing in all these things is apathy. And if people get what often happens with confusing or like overly complex stuff is no one ever likes to admit they're stupid. A lot of people are very worried about asking questions, and look, like there's that old adage that you're better to have people think you're an idiot than open your mouth and have them confirm it, right? That's kind of that I think plays in a lot of people's minds. It's never a problem I've ever had. I've always thought, I don't care if people think I'm stupid, because they probably are going to anyway. So I may as well learn what I need to learn. But a lot of people won't do that, and it just means they don't engage. And that's kind of the reason. That's always my kind of main concern is, how do I get them engaged, and how do I tell them whatever it is I'm needing to do? And from your point of view, who aren't necessarily, you're on the other side of the table, what I would suggest is that you demand these kinds of things. Like, I don't want to see a lot of tables initially. I mean, maybe I do later on when I need more detail, but show me a visualization and show me something simple. And even if it's a complicated question, demonstrate that complexity somehow, and that's the art of this stuff. I mean, there is no magic bullet. It is kind of a whole question of just trying a bunch of things and seeing kind of what works. And, and again, just nice and simple, clean line charts, keeping it all, very, very simple. But, we can always put things on a map as well. We've got location data. We showed this before. We can show the claim rate by region. This is always good too. It's a great way to get buy-in. People like looking at maps, and they like seeing where they are. And most people understand the basic concept of a heat map, and we can quibble over the color schemes and stuff, and whether or not how the things work. If you're colorblind of the various types, it's probably worth checking that as well, which I meant to do for this, and I think I did check this actually. I think this is okay, but I'm not sure. I wouldn't like to bet my life on that. I'm pretty sure yellow and red is okay, but there's different types. There's actually a brilliant talk online about choosing a new color scheme for a library called Matplotlib, which is a Python library. And there was a guy gave a talk about 7 or 8 years ago talking about the difficulties of creating a good color scheme, and he actually gets into the biology of the eye, which is fascinating. It's about 20 minutes long. I always come up with things on the fly here that I never have a link for. Damien, just remind me later, I'll provide that link. It's one of those talks. It's about a very technical subject that's just universally interesting to almost anyone I've ever showed it to, even if you're not, because it's not particular. It sounds very technical, but it isn't. It's the whole topic of color blindness, and also how the human eye can discriminate color is a really interesting topic. And you also see how terrible some color schemes are, because he uses the Mona Lisa as a way to, and just using different color schemes, he shows you how different color schemes completely blur the picture, whereas a better color scheme, you can kind of see the Mona Lisa in it, even though it's kind of two colors. But anyway, look, I'm going off on a different tangent again. So yeah, so we can do it on the map. Now, I mentioned this before, so I actually tried it. It did occur to me that the problem with maps is if you need a second dimension, like how things are changing or some sense of uncertainty, it's difficult to try that. So I actually tried to create an animation on the map. It's a bit crap, and it doesn't always work. It kind of, let me just, yeah. So what I'm doing here, I've kind of taken these uncertainty estimates and I've looked at the different quantiles of those estimates, and then in a little image that's cycling round, it's going from the lower quantile to the higher quantile. So you can kind of see where the highest variations are as the colors change over time. And at the higher and the lower rate. Personally, I think this is a bit crap though, because again, falling under my example of it should be immediately obvious what's going on with this, and it's not. You can kind of see some things are changing, but you're not. It's very open to interpretation. So my advice is to this is, well, actually, that's not fair. What I would say is that I wouldn't try and do this with a map in future. I've learned my lesson, which I kind of used you guys because I didn't know how this would work out. I actually thought it would look a bit better and a bit cooler, and then it looked terrible, and then I was going to take it out, and I went, no, a counterexample is a very good one. This is a good example of me creating a really terrible visualization, because the map is good, but to be honest, I would just do that and leave it there, because it was actually quite a bit of effort to create the video as well. So the payoff to effort is very, very low. Although I did kind of learn how to make animations, and that could be useful in the future. So it wasn't a complete loss. But yeah, I wouldn't expect you to have understood that previous one. And also it didn't work properly. Yeah, there was all sorts of reasons just not to bother. But yeah, so the problem with maps is, while it's great if you've got like unidimensional data that you're trying to explain like locations with, it's great. But as soon as you try to add extra values in, it just gets messy. So again, they're not always the be all and the end all. The other thing we sometimes want to do is we want to compare things, and making visual comparisons across things are very important. And again, I stick to my bar charts and my plane charts. So what I've done there with the data is I've looked at the proportion of claims by currency amount by region, and then the proportion that each region takes up, and then compared that to the range of exposures. And logically, what you would usually expect is that, if something is a function of the exposure, then there's generally a relationship between higher exposure leads to more claims. And that doesn't necessarily mean that there's something wrong, or there's something like idiosyncratically wrong with that particular region, or bad or good. It just means that it's got a higher population or a lower population, and you would expect that your claims would go up and down with exposure. But it's always good to check that, right, to make sure that you don't have something that's way off. So again, I just created a very simple bar chart. I went to hold on a second, I'm just seeing if there's sorry, I'm just getting, I see a couple of questions in there that I mistakenly looked on, but I will address them in a minute. You can kind of see here that, broadly speaking, that the various places that have the most exposure also have the most amount of claims on them. So that would suggest to me that, the region isn't necessarily very predictive or influential in where the claims are being made. It's more of a function of that some regions are more populous than others, or you have more business in some regions, and that's what's driving the differences in region, rather than something about the actual geospatial location of it. But you could have that, and you do have that, like in a lot of motor claims. There are notorious hotspots in the UK, for example, where claims are just off the charts in comparison to their population or the exposure of the business. And you would find that in those charts, because you would just see, okay, here's the population, here's the exposure, and oh my God, look at how big the claims are. Particularly a couple of areas in the north, in Yorkshire and Merseyside, are particularly notorious because there's a lot of fraudulent stuff going on. Whereas here we see that that's probably not the case, right? Because, okay, there's a couple of differences down the end, all right, but broadly speaking, it's not too bad. Now, the other way this often gets done, which I think I show in the next slide, is that people sometimes stack things. I'll talk about that a little bit later. I generally don't like stacking things either. And I'll talk about why. I try to, whenever possible, put things side by side. And the simple thing is, it's how the brain works. So we are very, very good at distinguishing between lengths. And just to give an example, I think most people almost immediately will spot that. If you look at that very first category, Alsace, you guys can see my pointer. And Damien, yeah. So you can see almost, even though the difference is very small, you can almost immediately, we can tell that, the exposure rate is a bit higher for Alsace than it is for the claims. And that's a very, very small difference, but the brain is very, very good at processing that difference, right? So try to make like side-by-side length comparisons is actually a good thing that our brain is good at. Now that sounds really obvious, but it's so obvious, it's because it's the way our brains work. There's nothing inherently easier about it. It's just because that's the way our brains process this information. So when you're getting visualizations like this, you try to want to lean in to how our brain works, because again, you're trying to tell the story, and it's like you're telling a story, you always want to tell a story in a way that allows people to actually understand the story, right? Don't make things hard for people. Keep it nice and simple. There's that age-old thing of like user interfaces and design. It's don't make me think, and that's a great example of that. So kind of lean into that. But we can give it an example. Let's compare region by fuel type, right? So this is a stacked plot. So we've got basically in these cars here, part of the policies is some cars are diesel, some cars are use petrol, and this is a stacked plot. Now, to me, I don't really like this, but you do see this a lot, and I don't like this because, for example, if you look at Saunter, right, it's kind of saying that it's roughly 50-50 across fuel type, but we can't really tell which is which. Now, you could probably, by going across, and it seems that it's slightly above 50,000, and it's slightly above 100,000, so probably regular is a little bit longer than diesel. I actually can't remember. I would always put them side by side like that. I think that's a much better way to see this information. Now, it can be useful sometimes to tell proportions, but even if I was looking at proportions, I think I would still want it this way. Now, that's just me, and obviously you have to tailor to your audience and see where things going. Let me just, I noticed there was a couple of questions. So let me just ask. Actuaries, accountants love the tables. Yeah, I mean, I'm not an actuary, but I kind of do that kind of actuarial work. I'm about as technical and nerdy as you get. I would always want the data as well, but it's not the first thing I want to see. The first thing I want to see is the visualization, because that provides the context that then allows me to get the increased information. So that would always be my go-to first, is always show charts. And again, there is a certain amount of, from my mentality, people who think like me can often be suspicious of aesthetics, because it's often used to blind people and bedazzle people, and that puts a lot of people off. So we tend to be very suspicious of like slick presentations that look really good, because the first way my brain goes is like, where's the BS that this guy's trying to, or woman is trying to like blind me from? So I want to see the details. So by all means, always provide the details as well. But the point I would make is I would always want to see the visualizations first. And then you can always provide as much data as you want. Engineers are the same. Lots of professionals try to justify themselves by making everything. Absolutely. That's, and I'm not sure if that's, it's very easy to dismiss that mentality as being like a certain amount of insecurity in their position, or trying to, and I guess it could be, because I've always found the people who are particularly good at what they do are usually very generous with their knowledge. I think for a couple of reasons. One of it is that I think there's an inherent comfortableness that comes from the fact that they know they're really good at what they do, and they know how hard it is to replicate. So they're not necessarily threatened by other people and by sharing, like knowing the precious things that I don't want to share with anyone else. I think there's an element of that, but also I think it could be just cultural as well, is that like sometimes you just, the way things are done is to just have all of this. And again, no one wants, like the emperor's new clothes, right? No one wants to be the stupid person who puts the hand up and go, I haven't a clue what anyone's talking about here. Can we please start again? Because also there is often quite a narrow window to say that. And if at some point you don't take that opportunity, then the opportunity passes itself and you're kind of caught then. So even if people kind of want to speak out, they kind of feel like they missed their chance to do so. So, I mean, it's definitely a phenomenon of it. And there is definitely a certain amount of, there's definitely a type of software developer / data person like me who have this kind of intellectual snobbery as well. And it's like, I'm very smart and I can understand this. And therefore, you're just stupid because you can't follow it. Whereas again, it goes back to the point I've always made about, I think I made this in the very first lecture, is that if you look at elite sports people who are probably as diametrically opposed to an engineer and someone like me as you can get, the key thing they always do is they do the simple things really well, and they make things look very simple, and they don't overly complicate things. And sometimes they do things that are just incredible, and you kind of have to look at it again, but it actually seems effortless, right? It doesn't look complicated when they do it. So to me, that's always, but again, that, we're, like everything else, it's always about culture. Culture just kind of pervades everything. But yeah, it's great that people are making comments. By all means, keep them coming. So yeah, so just to kind of keep going on the point, how are we doing for time? I'm a bit ahead of time for once. It's not like me. We're going to compare region by vehicle brand, because, so I was preempting all the arguments. So I was kind of thinking, okay, well, how do I attack my own argument? I was saying, well, that's all very well and good, Mick, but you're dealing with a fuel type here, which only has 2 levels. So of course you can stack them side by side. Of course, that looks great. It doesn't make sense to stack them. So I was like, okay, well, there's a vehicle brand which has, I think, 8 or whatever that is. There's not, it's weird. There's no B7, B8 or B9. So there's actually 12 or 11 different brands. And that's the stacked plot I did there. So basically, it's a total exposure, and we're looking at the different regions. To me, I mean, I don't know how I feel about this. I don't particularly like it because I can't really tell the difference between the big brands. So So I don't, you know, it's not great. And of course, if we try and do that, I mean, I guess it's a bit better. It's kind of hard to distinguish the colors. I mean, again, the point I would probably make here is the way to solve this problem is to reduce the number of levels. So if you're making a description, for example, just choose the top, never have more than 5 in this kind of plot, for example. If you have to break up your data and make some comparison plots side by side, I'll often do that as well and show them all at once, right? This isn't a great way to do it, though, I have to admit. So sometimes you can just use faceting, right? So what we're doing here is we're essentially subsetting all the different data sets into different brands, and then we're producing the same box plot together. Now, what I've created here, now this is, however, this is the other thing you can do with faceting. Sometimes we'll have 2 different scales, though, on the y-axis, or like, so do we want to compare it this way, or do we want to compare it that way, where we have a fixed scale for everyone? And they both have their benefits, and often I will do both, because sometimes you want to get a sense comparing across the brands. And in that case, you kind of need a fixed scale to get the visual look. However, the flip side of that is this is a terrible visualization, right? Most of it's empty white space that isn't actually useful space. It's just a feature of the fact that you're working on a different scale on all of them. So I mean, we could try and come up with a common scale for everything, or we could just do this where we have a free scale on each one. But the problem there is when you're comparing across the different brands, it's harder to compare the exposure sides. Now, I think from my point of view, like if I was talking to you, again, it would depend on the relationship, but what I would probably do is have this conversation of how do you want to see this? And then show you a bunch of stuff. And then you can, because everyone's different as well, right? And sometimes it's the way your mind works. Sometimes it's pure subjectivity. Sometimes it could be as stupid as I had a completely terrible boss at the start of my career, and he loved facet plots. So I hate facet plots now. Like my wife hates goatees because she had an early boyfriend who was a terrible person. And as a result, now I'm never allowed to grow a goatee because, you know, life is just simpler that way. But, you know, so sometimes you have to kind of play to that completely unreasonably subjective stuff to play, you know, to do things to your audience. So like, if you're on the other side of that, be kind of open about that. Say, look, I don't want to see anything too complex. Try to be as explicit as possible about the things you want to see. Or if you don't really know what you want to see, like have a conversation about it and ask. But like, now that what I'm trying to do is like, these are kind of ways in which data can be presented. Just ask people for it. I mean, in many cases, the classic person from my point of view is people say, I want you to do some stuff with data and I have no idea what I want. And then so they go off and do something. And so that isn't what I wanted. It's like, well, you didn't tell me what you wanted, so I had to give you something, right? So if you can actually have a conversation, even if it's a very, very high level, I want to get some sense of how these things work. And maybe if you could show me some plots or some things. And, you know, I saw this presentation once and this was an interesting visualization. Could you maybe do something like that? Those are great steers to give people because you're starting to make things a lot more concrete. But again, you know, it changes. So that's how we're doing for time. 10 past. Is there any more questions since? I don't think there are. No. All right, so we're almost at the end of the topic that I had prepared. However, I will discuss pie charts. Now, pie charts are terrible for various reasons. The biggest reason is that, going back to what I'm saying about the human brain, we are not good at distinguishing angles from things. I'm going to try and give a couple of examples of why parts are charts. Now, actually, pie charts are so bad that in a lot of programming languages now that are data visualization based, they actually make it difficult to make one. I actually can't make a great pie chart of this data because I kind of had to look something up and say, how do you create a pie chart in R? Because under ggplot, because they very deliberately said we are not implementing this because it's kind of universally accepted now in data viz circles that pie charts are just not really fit for purpose. They're at worst like not very useful, and at best not very useful, and at worst sometimes outright misleading. So just to give an example, we were talking about that exposure by region, right? So I've looked at all these exposures. This is the plot we were kind of talking about before. I haven't compressed everything down. This is just, you know, the simple summing of all the exposures. And that's the box plot of it, right? Or the bar plot, right? So we've simple bar thing that we had before, and that is the pie chart of it. right? And so, you know, you have a lot of different regions there. It's, you know, it's very hard to tell, you know, how is, also because you have lots of different colors. Now you could change this a bit, I guess. You could have more distinguishing colors across one another. So it's a bit unfair from that point of view, I guess, that you could come up with some kind of like things beside each other on the pie chart have more distinct colors between them. So I could definitely improve that. But even ignoring the color schemes, it's just very hard to tell. For example, if you look at this orange one here, which is Aquitaine, I think, versus this kind of light blue down one here, I think this is bigger, but it's kind of hard to say. We just don't process that well. It actually gets worse because people often do 3D pie charts where they tilt it onto one side. So you really have no idea how things. The one time a pie chart can sometimes be useful is if it's literally a 2-value thing where it's A versus B, because then you get the sense of that. But in most other cases, it's not. Now, the reason why pie charts are so ubiquitous is it goes back to Florence Nightingale. The first that data visualization thing she created in the 1830s, whatever it wasn't quite a pie chart, and she invented it herself, but it was kind of, it used these kind of angles, and she had different lengths and stuff. She had a few different visualizations going on in one. And that kind of became, you know, it just kind of went from there that people started using it. But I never, like I said, I've been doing this kind of stuff since the early 2000s. Obviously I've done them in Excel, but despite that, I actually had to look up how to do this and code it. It wasn't particularly difficult, but it was a bit of a pain, and it's not nice, and it's very deliberately been, and most of the Python libraries are the same now. They don't make it easy to make out of the box as a very different thing. But like I did say, it's possible I'm coming up with a strawman argument here because there's loads of different levels. So maybe let's aggregate. So anything that's under 10% of the exposure, only 10% of the proportion, let's aggregate that into a big box. So this goes to the plot we had before. Okay, so this is the bar plot that we had earlier. So you can see the other. So there's a big chunk of other here, and this is the bar plot, right? I still don't think this is great because, I mean, you can kind of tell that Ile-de-France and Provence are, and you can tell Ile-de-France is a bit smaller, but it's still kind of hard to say. And then is the two of them combined bigger than the blue? Hard to say. I just think this is a much easier read on it. I just think that displays the information much more unambiguously than a pie chart does. And then let's just go down a bit further then with a bit more resolution. We have, you know, these bar plots like this, and you know, I hope I've convinced you. Just please don't. If someone gives you a pie chart, please just ask them to create a bar plot instead. It almost always will give you the exact same information in a way that's much more usable, and that's why it's, like I said, it's been universally kind of discussed because people just know how the brain works now. You know, it ties into a lot of neuroscience and all this kind of things in terms of how the brain processes information and thinks about stuff. I'm sure this is a controversial topic. I don't really care. This is one of the few things I do actually get bolshy about, in that I know I'm right on this topic because but people like their pie charts. So, you know, okay, sometimes sometimes it happens. There's a good way about other. Is there a good way to present info? That is an excellent question. So this is, I mean, I didn't want to get into too much detail on this because I was very conscious of, this was what I was saying when I was kind of writing this talk. I kind of wrote it as if I was giving this talk to Dublin Data Science or something. It's like, here's some things you can do to visualize the data to present it to non-technical people. And I realized actually who I'm talking to are the non-technical people. So getting into the weeds of doing the data viz, I tried to shy away from. You could, yeah, you could. There's a few different ways you could do it. You could put in that's off the top of my head. This is how it becomes more of an art than a science. You could actually just put it in the chart, to be honest with you. You could put it in the title. You could just say other, you know, total exposure by region, and then in parentheses, other consists of all the values of this, and there's 15 of them in there. The other way you could do it is to have a plot of everything that's in other. So you basically recreate this bar plot, taking out these 4 values here, and then just have another bar plot showing this. Or, I mean, or you could just go back to the other one. Where is it? Back here, where it's just, you just show everything. You know, you kind of, I mean, it's not too bad now. That what typically happens, I mean, this is somewhat weird, at least for a lot of the data I work on, where you're only talking about 20 or 30 different distinct values. When you get to a couple of hundred, suddenly this isn't very useful, especially if you get this, what's called this long tail. So you get a large number of very, very small contributing categories that it's very easy to ignore, but sometimes they're also very important. So you can't just eliminate them from your analysis. Sometimes you maybe just need to stick them into a big bucket, but then it's useful to know, okay, everything, but we're going to ignore everything that's like 150 or 300 categories, and anything that's less than 1% of the proportion of the quantity that we care about, and there's 200 of them, we're just going to aggregate them down, but that aggregate might come to 13%. So the other issue you sometimes get is if you're plotting them in order, you will sometimes get this weird thing where you have, where is it? Hold on, let me just bring it up here. Sorry. Where's my, that's what I get for doing things live. I'm looking for the bar plot. So, you get, is that it? No. Yeah, here. So you can kind of see here, you have, let's say you do this in order. Quite often what you'll naturally organize it in some kind of order of size, but then other is kind of this big jump up. So how you manage that, and sometimes it's weird to put the other in the middle. It's nice to kind of have all the very specific values, as the first ones, and then have, the big dumpster box at the end. But then sometimes it looks weird because you've got this, declining Y value, and then at the end you've got this big spike. So I mean, it's very, very hard to say on how to do that. But I think that, just to go back to your original question, I think that's how I would deal with the other there, is that I think if it was important to break this down, I'd probably on the title, I would say how many values are in the other, and that's probably something I should have done, actually, to be honest with you. Now I think about it, I should have put in like how many regions are in that other box. And the other thing, but then I think to break that down, I would just create another box plot. I would create, another bar plot where I just looked at those specifically to see. Now, the other thing to remember though, is if you do that though, you're going to change the Y-axis. So if you're putting the two side by side, you've got that faceting issue that you have again. It's kind of swings and roundabouts. So that's most of what I want to talk about. I did want to kind of just give a few, for people who are interested in this kind of stuff in general. The classic book is a guy by Edward Tufte, The Visual Display of Quantitative Information. I actually owned a copy of it, and it's still in Canada from 10 years ago, kind of lockdown style. I left Canada with a bunch of books in it, thinking I'd be back in a month or two, and then things changed in the job, and I ended up never going back for it. So it's still in a friend's house in Canada, but you can get it online. I think there's some PDFs of it available in certain places, or you can save excerpts of it. It's a relatively thin book. It's maybe only about that. It's kind of in a hardback, and he was kind of the very first proponent of like essentially data viz minimalism. So he's all about keeping things very simple. Don't overload with colors. Don't overload with flash. All that does is obscure. Keep things very, very simple, crisp, and talk about a lot of stuff. He's probably considered outdated now. I mean, there's a lot more research has been done, but sometimes the classics are great. And I think starting here is a very good starting point for anyone interested in this stuff. I have another good book at home though called Visualize This. It's by a guy called Nathan Yao. He has the website Flowing Data, which was kind of one of the first websites to really kind of start showing data in a useful way that was also very kind of aesthetically and visually appealing. And he has a whole bunch of different data viz ideas. The interesting thing about this is, you don't necessarily want to do too much reading on this stuff. What you really want to do is kind of look at how things are done and kind of learn by example. And this book is very, very good for that stuff. Whereas the other one is a little bit more Spartan and a little bit more kind of academic. Whereas this is much more modern day, kind of easier to digest and a bit easier to use. And they're all of these are very readily available in most major booksellers and whatever. And There is a few more. There's also Information is Beautiful, which is a website, and I think they have a book based on it. I just didn't want to recommend that because I don't own it, but I know it's out there and it looks pretty good. And a quick Google as well, if you do an internet search for books on database, they actually give you, there's quite a few articles out there. Was a lot more than I expected, actually, that give you a good list of books and like some summaries of them. And there's a few particularly useful ones, but again, I didn't want to mention them because it might not suit you, or it might not, it's something I might not agree with, but again, we're all different. So I don't necessarily, and I'm very, very conscious. It sounds like I'm being a bit overly protective here, but I am very conscious that like data visualization and aesthetics are incredibly subjective to people. So I'm also very conscious that what might not be great for me might be actually what you would want to see, if you know what I mean. And so therefore I'm a little bit reluctant, because what I would do isn't necessarily what you should do, because most people are. There's a certain difference amongst all of us. So you kind of have to do a bit of, it is a bit of a thing. So that's kind of where I've got to. I didn't really want to do any more than that. There's a load of different things we could have talked about. I was tempted to put a few slides in for those horrible data visualizations, like the chickens and that pirate thing. But again, I wanted to keep things a bit more. Here's things to do and why I'm doing them, because it's very easy to get a cheap laugh. And while some people do need to be mocked mercilessly so that they're never tempted to do it again, I felt like I'd already I'd hit them with the stick enough, so I kind of decided to leave. But there's loads of things like logarithmic scales versus linear scales, the whole use of color and shapes and stuff. I didn't really want to go down there because I don't use them very often, and I know there's been quite a bit of work done on that. What I didn't want to do was basically talk nonsense about something that I don't know an awful lot about, or just to talk like an authority on something that I had Googled like a day or two before. But I do know like the whole linear, like one-dimensional length versus two-dimensional volumes. Volumes can be useful in some cases, but you have to be a bit careful, because again, the brain isn't as good at distinguishing between volumes for a similar reason that pie charts, right? You're kind of into the same category things, but sometimes it can be very useful to use, like instead of different circles for points, you will have stars or squares to show different elements of things, and you will often see that in terms of aesthetics. So there's a whole bunch of work on that, but again, like I said, I'm not an expert on that stuff. Like I said, you've seen most of my data viz production. I don't generally get much fancy, apart from like a line chart, and I'll use different colors and maybe put labeling on, but I try to keep things as absolutely simple as I possibly can, and then just think about how can I use these basic tools to convey whatever kind of message I'm trying to convey. So that's about it. So what time is it? I think we're kind of, I've pretty much hit the mark. Perfect. I'm getting better just as we're about to end. Perfect. So yeah, I've left it there. I think next week, what I'm going to try and do is talk about how to bring data into your organization, like how to get started. It'll be, again, very high level in terms of culture and stuff like that, but just suggestions for things to maybe, if you feel like there is more that could be done and that you have a certain amount of tacit approval to explore these kinds of things, here's how you might start, and how to look at that. So this is end of the technical stuff, and then for the final week, which will be week 8, it'll be just kind of a tying a bow and everything and summarizing what we've talked about over the previous 7 weeks. But yeah, thank you. Sorry, Demi, you're back on there, are you?
Yeah. If anyone has any questions, or I actually had one, a quick one for you, Mick.
Yeah.
In place I used to work previously, they were big fans of seeing everything in kind of time series, like you were saying, on a line chart, and then we'd have the year-on-year delta on the bar charts. What's your feeling on those dual axes type ones?
So when you say dual axes, do you have like one y-axis is one value and one y-axis is another? They are terrible.
Yeah,
they are absolutely terrible. They are a great way of spurious correlation, because they're also, most packages now make them difficult to do for that same reason, because they're generally more misleading than they are helpful, and it's very easy to get there. So going back to my earlier point about what you want to do is, the first time you see a visualization, you should have a rough idea of what you're being told. They tend to obfuscate that, and they're generally, like, I would be incredibly reluctant to produce that for someone for that reason. Because what will happen is, because it usually happens, is that I'll be right, and then I'll be in the land of I told you so, which is a place that no one wants to live in. Well, everyone likes living there, but realistically, everyone else hates you living there. And it's just, you're just bringing, so like I generally get very, very strenuously to say, look, I'll do this if you want, but, you know, I think this is I'm going on the record, this is an incredible, or you just come up with a reason for why it's very hard to do, because it usually is actually. I think Excel makes it relatively simple now. Yeah, but all the stuff I do, I generally don't do it because it's kind of hard to do. And it also doesn't do, basically the question I would go is, what are you trying to figure out here? Why are we doing this? And then come up with a way that I will actually convey that message. But I will say though that, to go back to your point about time series, if time is one of the columns that I'm talking about, I will almost always do it as a line plot, unless it's some kind of categorical value. And even then, if it's categorical, you'll just have dots at each point in time, and then you'll have, you know, and then you just put, so it's basically, it's not necessarily a line, but you're seeing how things change over time and what category it's in. But generally, I will almost always do a line plot with that. I wouldn't do a bar. I wouldn't, like some people I've seen, they'll put things into boxes. So they'll group by day, let's say, and then do a bar plot by day. And sometimes you can do that. That can be useful too if it's a summary. But quite often what I instead would do is I would just plot each time. The time point is essentially a continuous number, and that becomes and then you draw a line then. So you have time on the x-axis and some kind of continuous value on the y. But yeah.
So it'll join the pie charts in the dead to us.
There's been a lot of discussion about that online, about why it's really, really difficult to actually, it's really, really easy to interpret that kind of chart wrong. And then you're and misleading and going down the wrong route. And of course, people never blame the chart. It's always someone else. But that's ultimately that's where it starts, because you see these things, you in your head draw a connection that isn't actually there, that is purely just a function of how you visualize the data, and then you're off to the races and going down a bad road. So I can't remember who said simple is very difficult. Yeah, so the other thing I always say is that there's two axes and people conflate them. There's the simple and the complex, and then there's the easy and the difficult. You know, I think I mentioned this in my simplicity talk. It's very hard to do things simple. You know, it generally actually takes a lot of time and effort. A great example of it is bad dancers. So when you see a comedy bad dancer, they're usually excellent dancers, because you have to be that good to look that bad, because it actually requires a lot of timing and precision. So it looks like you're just doing the simple thing and you're just kind of clowning around. But usually those people who do that are actually really, really good at what they're doing. And, you know, to get off, to be that bad, where it's comical, it's thing and say, why simplicity? Yeah, I mean, and I won't lie, I mean, you can slickly present something, but if there's too much flashbang whiz, I immediately think people are either two things. At best, they don't know what they're doing and they're trying to cover it up with being overly flashy, or B, they're actively trying to mislead me. Now that
we might have lost Mick there for a second. He might come back. No, Mick, can you still hear us there?
Not kind of doing much, right? Whereas when you're comically bad, it's actually very, very hard to do. But anyway. So yeah, so thank you very much. I think we'll leave it there. I don't know if I'm getting any more questions. I don't think we just a couple of thanks. It's just great to see. I hope you're finding this useful. If you have any ideas for things you would like me to, issues that you can kind of preemptively anticipate, if you try to do this some kind of data thing internally, by all means, make some suggestions. I'll have a think about them and I can probably address them next week. If you want to do that in advance, great. I mean, I'll happily take questions on the day too, but if you get to me a bit in advance, it'll give me time to have a think about it and come up with a couple of ideas. But yeah, that's kind of where we'll leave it. How are we doing for time? Yeah, we're pretty much on bang on. So yeah, thank you very much. And I hope you found it interesting.
Thanks very much, everyone. We'll see you again next week. Thanks very much for your time.
Bye-bye.